How long ago?
It was like, I think it was like one day. It was like 3 hours last week. Yeah.
It was like my favorite teacher.
I know. That's no way. Remember when we like had like
Let's go. Time to get and let's pay real close attention to the details. Dana, we'll pay real close attention to the details here.
Yep.
And maybe we'll have issues going forward. All right, label as a power function, an exponential function. Okay, so let's look at our choices here. Does anybody have any idea about any of them? Jake?
I think number 1 is a power
This
function.
is definitely a power
And then
function.
number 2.
Okay, hang on. I'll let you finish in a minute. Power functions are anything, any x raised to any power. So x to a power, like x squared, x cubed, x to the 8, x to a power is called a power function. And that power can be any kind of number there. So x to any number is going to be a power function, okay? Now, be careful. This is neither. Because when we say x to a power, we mean that power is a number, any number. X to the x is something new. Okay, that's in its own category. All right, Jake, what were you going to say then?
I think B is the exponential function.
Exponential, because exponentials are a number to the x. Okay, so power functions are x to a number. Exponentials are a number to the x. This is an exponential. Perfect. What do you think about this?
Neither.
Neither, there's no x, right? That's just 16. So that is neither. So this is power, this is exponential, those guys are neither. This one in a very, very, what I want to say, kind of broad view, this could be thought of as a power function, because what's x to the 0? 1. So do you see how that's the same as this? So it could be thought of as a power function, but that's kind of an anomaly. It's a straight line. Okay, find the value of the function for each given x value. No calculator. So for A, 3 times 5 to the 0. They're telling me to plug in 0. So Dana says that's 3, is he right?
Yeah.
Yep, because 5 to the 0 is 1. Okay. 6 times 3 to the negative 1/2.
2/3.
So 3 to the negative 1/2 means 1 over 3 squared. Do you remember that? And that means 6 over 1 times 1 over 9. Remember, I'm not using the calculator. I'm going to have to be able to do this without a calculator. So that's 6/9, which reduces to 2/3. What?
Can you explain how like you got the fraction out of the negative exponent?
How do I handle negative exponents? Jake, we talked about this at the beginning of the year. 1 over. Negative exponents. Negative seconds, 1 over. Right? All right. C. Y equals negative 2 times 3 to the 1/3. All right, now this is a little tricky. That's a radical, that's right. So Elijah says that anytime, I'll just use that example, anytime you have a fractional exponent, you have a radical. okay? Fractional exponent's gonna be a radical every time. Under the radical is gonna be the base. So this is a little confusing because that's a 3, but this goes under the radical. The exponent, the base of the exponent tells you which root to take, and the numerator of the exponent tells you what power to raise it to. So this means the cube root of 3 to the first. The cube root of 3 to the first. Okay? Now, the cube root of 3 isn't anything except the cube root of 3. So my answer is just negative 2 times the cube root of 3. If this had been a cube root of 27 or something, I could deal with it, but not the cube root of 3. Alright, and then 8 times 4 to the negative 3 halves. Now, first of all, let's deal with the negative, Jake. This is 4 over 1 to the negative 3 halves. So it's going to become 1 over 4 to the positive 3 halves. Exponents do not flip, ever, period. Exponents do not flip. Exponents become positive when you flip the base, but that's going to be 3 halves. This is going to become 1/4. Okay? Now, what do fractional exponents mean? Radical. So we have our 8, then we have a radical with a 1/4 under it. It's the square root cubed. What is the square root?
1/8.
What is the square root of 1/4? 1/2. But you gotta cube it, so you get 1/8. So we have 8 times an 8, so the answer is 1.
Is there no plus or minus?
Oh, great question, because you square rooted, you mean? Technically, yes, but we're getting ready to study exponentials and the base is never gonna be negative, so I'm going to say don't worry about it. But technically, yes, very good point. Very good point. Yep, great point. Now, if any of that bothered you, you might want to take a look at that worksheet I gave you, because it just has practice on it. The answers are in Canvas. You can work some of them, all of them, none of them, I don't care. But you are expected to know how to handle negative exponents and fractional exponents. So if you're unsteady with that, then do a little extra practice. All right, now we're moving on. We're going to write the equation of the exponential function. So, first thing, let's make sure we're all clear that this is the format of an exponential function. Now, if you think about the things that we've studied so far, we studied linear functions, and didn't they have a format, y equals mx plus b? And then quadratic functions, ax squared plus bx plus c. Every type of function has its, like, this is the way they look. Exponentials, this is the way they look. So a number times a number to the x. So your job is to write the one that has f of 0 is 3 halves, and f of negative 2 is 108. Now, remember, this is a point. Would you agree? This is a point? What point is this?
0, 3.
0, 3 halves. And this is -2 comma 108. And that's my goal, right there. So if I look at this ordered pair, this is an X and this is a Y. So what if I plugged that X and Y into my format up here? So 3/2 equals A times B to the 0. Remember, this is X and Y. So it's going in here. Does that look okay? What's that?
One.
So A equals
3/2.
3/2. So I already know that this is 3/2. Well, what do you think I'm gonna do now?
Find B.
Oh, yeah, how am I gonna find B?
Plug
I'm gonna
in
plug in the other one. So 108 equals 3/2 times B to the -2nd. Now, there's some arithmetic here. You can handle it, but there is gonna be some arithmetic.
Which one is the
I gotta get rid of this,
multiply?
right? So, I could divide by 3/2, or I could multiply by 2/3. Would that accomplish the same thing?
Wait, would you not multiply the B too?
I'm getting rid of this number.
Oh,
I'm solving for B, that's my variable. So 2/3 of 108 is for 72. You'll have a baby calculator to help you with this if you need it, but I think it's 72. At least I hope it's 72. And then, what do I do now?
Square root.
Well, I gotta be careful, that's a negative exponent.
By half.
So, no. Let's make the exponent positive.
Oh, 1 over B.
So 1 over B squared. So 72 over 1 equals 1 over B squared. So if I cross multiply, looks like B squared equals 1 over 72, is that right? Is that okay? And now I can square root. So B is 1 over,
6 root 6.
the square root is 72. Is that 6 root 2?
36 times 6. Or yeah, 36 times 6. 6 root
So 6 root 2?
Yeah.
Really don't like that down there. So do you remember what we do when we have a radical in our denominator?
Yeah, multiply that.
So we'll do this. So I got root 2 over what?
24.
Watch it.
Or 12.
12. Because that's 2. 6 times 2. Well, that's not very pleasant. Like 3/2 times root 2 over 12 to the x. When I made up that problem, I did a terrible job. Usually they're not that yucky looking. Alright, I'm gonna have to erase it though, so before I do that, is there a step up there that bothered you? Everybody okay getting 3/2 for A?
Can you just, or did you just flip the fraction, right, because it was B to the -2, you just flip it, and then got like this, like 72 over 1, so we made it.
So I just lost my reply,
Yeah.
because I'm solving for B, so I don't
I'm so.
Alright, well, here's the good news, there's another one. hopefully it's not as messy as that one. All right, but here we go. We want a times b to the x. That's our goal. Our 2 points are 0, 3, and 2, 6. This one's going to be a lot nicer. All right, so here we go. Find a. So 3 equals a times b to the 0. So a is 3. So now I know a is 3. And now I'll plug in 6 equals 3 times b squared. So 2 equals b squared. And b will be the square root of 2? No, because in an exponential, b has to be positive. That's what I was telling Dana. In regular problems, you could, but not in this case, that has to be positive. So my answer is y equals 3 times the square root of 2 to the x. So that last one had a lot of arithmetic going on, but you don't have it now. This is easier, already follow those steps. In number 4, we're looking at some transformations, but let's start with the basic curve first. Y equals 2 to the x. Can we come up with some ordered pairs? So we have some points that we can plot. So let's just use our regular old one. Remember when you were a little kid and your teacher made you do a table of values and you plugged in x's like this? We'll just use those. So -2 is going to give me 1/4. 1/2. Very good, Elijah. 1, 2, and 4. So let's plot these. So -2 are 1/4. -1, 1/2. 0, 1, 1, 2, 2. I'm going to go ahead and connect those dots. Does that picture make sense to you in terms of your BFF work? Remember, one of your note cards was the exponential, and it wasn't 2 to the x, it was e to the x, but the shape is that, right? That's what your exponential is going to look like. Now, the next, or the actual part of the problem says, what about 2 to the x minus 3? Now, do you remember what subtracting 3 from the x does? Moves it right 3. So it basically adds 3. So in my table of values, I'm going to take all my x's and move it 3 that way. So it's going to be 1, 2, 3, 4, and 5. Does that make sense to you? But the y's aren't changing, because in this equation, the only thing that changed was the x's. So the x's are changing, but the y's are not. So now I'm going to plot those points. So 1, 1/4, 2, 1/2, 3, 1, 4, 2, and 5, 4. What happened? I picked it up and moved it 3 units to the right. Does that make sense to you? That's what happened. Just moved it 3 units to the right. Okay. What about the next one?
Flip it upside down.
Watch it now.
Sorry.
Watch it. It actually is going to flip it sideways, but let's look at it in a table of values. What is happening to my x's? They're changing signs. So now my table is going to look like this for the x's, but the y's are staying the same. So I'm going to plot 2, 1/4, 1, 1/2. That one's not going to change. 0, 1. And -1, 2, and So is that what we expected to happen? Yes, because when you change the sign on X, you flip it sideways. So my dark blue curve, the dark blue one, got flipped sideways. We spent a lot of time back in chapter 1, I think, dealing with transformations, flipping things around, moving and picking up whatever. Back then, I just said, take your curve and flip it sideways, and that is still okay. But some of you struggled, so now I'm trying to show you how you can actually do it with a table of values if you want to, if that's easier for you. So I took my original blue ones, and I changed the X however the equation told me. So here it told me to change the sign. Here it told me to add 3. Okay, are you with me, everybody? Everybody okay? All right, let's see what's next. Oh, we're gonna do some more. Why don't you try C and D on your own? And then we'll talk about, yes. So, the original picture is the dark blue one. So it's the dark blue one that you are changing. Remember, a number out in front impacts the y, right?
Yeah.
So it's just gonna flip it upside down. So it multiplies your original by -1. So this is what you should have. It just took the original and turned it upside down. Okay? Everybody okay with that pink one? Yeah, that one's kind of easy. The green one now is a little bit weird because that's not a 2. But wait a minute, is it? What is 0.5?
You divide by 0.5.
0.5, isn't this the same as 1/2 to the x? And 1/2 is 2 to the negative first? See, this is where you know your exponents or you don't. You really gotta know that 1/2 is 2 to the negative first. So we have 2 to the negative first to the x, 2 to the negative x, which I erase, and then I have to add 1 to it. So this table of values, you guys, is gonna change both. Here are the originals. The x's are gonna become the opposite. Okay? And what's happening to the y's? We're adding 1. So 1 1/4, 1 1/2, 2, 3, and 5. So 2, comma, 1 1/4.
We're not multiplying the x by 2?
Okay, wait. Multiply x's by 2. Remember, my base function is 2 to a power. That 2 is part of the base function. Okay? That guy right there is this guy right here. So 2, 1, 4. So 1, 1 1/2. 0, 2, negative 1, 3. Okay, now when you draw this one, you gotta be a little bit careful. Clearly it's gonna keep going that way, right? Right?
Yeah.
Okay. The original has its asymptote at 0. This is where no matter which direction it's going, this is what it's going to. I have taken that asymptote though and done what with it? Up 1. So now my asymptote is here, and my picture looks like that. You don't want to bring that green curve down to the x-axis, because it got picked up 1, and that means your horizontal asymptote is going to go up 1. In a normal exponential, like on your BFF card, the asymptote's going to be at 0. And it's going to stay at 0 unless you add something or subtract something. That will move it up and down. Okay? So again, the table isn't necessary. If you know, oh, I'm going to flip sideways and move up 1, you can sketch that green curve. I just put the points here to show you how easy it is. If you know what you're doing, change the sign on x, add 1 to the y's, and then you can plot your new points. Okay? All right. State whether f of x represents growth or decay and describe its end behavior. All right, so there's 2 parts to this question, and I need everybody zeroed in here. So I'm going to look at the blue curve that I just sketched, y equals 2 to the x. All right, this isn't problem 1, this is the one we've already done, y equals 2 to the x. Would you say that is growth or decay?
Growth.
It's the terms are getting bigger. And the reason the terms are getting bigger is the base, the 2, is bigger than 1. The base will always be positive. All right? You're never going to have a negative number in that spot, ever. The base is going to be positive. But the base can be
Fractional.
like 2/3. or it could be like 8. If the base is bigger than 1, you're going to have growth every time. Okay? So when I look at problem A, what's my base? 3. So is that growth or decay? Growth. And if it's a growth, it's going to look exactly like that blue one. That's what growth looks like, period. Now you can move them around, make them steeper, but that's what growth looks like. When we describe its end behavior, we're going to use limits. What is the name of this function? So we're going to talk about the limit as x approaches infinity. Did you do this earlier? So we're going to talk about the limit as x approaches infinity, and we're going to talk about the limit as x approaches negative infinity. This is our limit notation for end behavior. Positive infinity, that's the right end. Negative infinity, that's the left end. Tell me what happens as I go right. Positive infinity.
Goes up.
It goes up.
Infinity.
Infinitely huge. It's going up, 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 up. That's what growth is going to do. Right? It's growing. Now, what happens as we go the other way? It gets closer to 0. And if you want, you can say 0 from the top, because aren't we approaching from the top?
But it doesn't ever equal 0.
Never equals 0.
But you would still put 0.
Yeah, the limit is 0. That means that the boundary for it is at 0. Okay, everybody all right with that? Now, look at B. Be careful with B. In the exponential, this has to be an x, not a negative x. So I'm going to have to rewrite my problem as 1/3 to the x.
Yep.
Does that make sense to you? That's going to be decay. That one's going to be decay. Those terms are going to be getting smaller and smaller. So the picture's going to look like that. When you analyze your exponential, make sure x is positive. Make sure x is positive. Okay? Limit as x approaches infinity, and the limit as x approaches negative infinity. This is the way you're going to write it. You're not going to get lazy. You're not going to try to shortcut it. That's the way you're going to write it. And then you're going to look at your picture. X is going that way. What's happening to my curve?
0.
Getting closer to 0. From the top. Here's 0. This is the top of 0. I'm on top of 0. And then what happens in the other direction? It goes up to positive infinity, yeah. In an exponential, and you're doing end behavior, one end behavior will always be infinity, positive or negative. And the other will always be the asymptote. So one side is going to approach the asymptote, one side's going to shoot up or down, depending on what the picture looks like. All right. How about the next one? Take a stab at the next one. Can you figure out whether it's growth or decay? This is letter C. Letter C. Can you figure out if it's growth or decay? And then can you find its end behaviors? I always graph mine. You certainly don't have to. I always graph them. So take a moment. See what you think. Is that already positive? I'm good. I'm ready to go. Is that number bigger than 1? Nope. So this is going to be decay. And as I go to the right, I'm going to 0. And as I'm going to the left, I'm going to positive. Anybody have a question about that? Please ask. Because the next one's going to be tricky. So Ronan, do you have an issue? Everything okay? Okay. The other ones have the issue?
We know who has the issue. Looking at past.
He thought it was gonna be gross.
Looking at past testing quizzes, we know who has the issue.
He thought it was gross.
Alright, here we go. Y equals, I'm going to change that to 3/4. Is that okay with you? Because I have to flip it, so that's, I like to have a fraction. But my x can't be negative, so I'm gonna have to flip that and make it 4/3 to the x. Everybody follow what I did there? Remember, don't make a conclusion, do not make a conclusion about growth or decay until x is positive. I want x. Okay? So now I can see that it's a growth problem. So the limit as x approaches positive infinity is going to be infinity. And the limit as x approaches negative infinity is going to be 0. Okay, you're with me there? You don't have much room on it. I'm going to throw one more at you. You don't need to write it down. Let's just talk through it. What about this?
Okay, that'd be growth because it's going down and upwards.
Okay, so let's just wait a second. If I took that out, that would be this. Agree? When I put a negative out in front of it, though, that tips it upside down. So this actually looks like this. Would you agree with that?
Would you ever have to distribute the thing? So you have to solve.
These can never get multiplied together. These can never get multiplied together. Does everybody understand that that right there is this? But when you put a negative in front of it, it's going to turn it upside down. Right? So what is the end behavior then? Well, on the right side, it's going to be negative infinity. And on the left side, it's going to be 0 from the bottom because we turned it upside down. That is not growth. That is decay. Now, normally when we talk talk about growth in decay situations, we talk about real life, like money in the bank, population. So this doesn't really come into play in real life. Mathematically, it's decay, but we're not gonna see that too much in a word process. No, you can't leave. You can shut your mouth and pay attention. Okay. Alright. Let's look at number 6. Let's get through these ones and then we'll be done with these 3 problems. This is a different kind of situation. Think back to your BFFs. You didn't have anything that looked exactly like that, but you had one that was formatted similarly to that. Does anybody remember what function it was?
It's
It was the
logarithmic.
Logistic. This is a version of the logistic function. Tell me what you remember about the shape of a logistic function. The shape of a logistic function, remember, it had 2 horizontal asymptotes, and then it squiddled up in between them like this. So your job is to find the y-intercept and the horizontal asymptote, there's 2 of them, okay? And we're gonna find them. Now, how do you find a y-intercept of anything? Plug in 0. So 12 over 1 plus 2 times 0.8 to the 0. What's 0.8 to the 0? So 12 over 1 plus 2? 12 over 3? The y-intercept is 0, 4. Let's walk through that again. This is going to be a semester exam question. I just know it. How do you find a y-intercept? You plug in 0 for x. So I put a 0 there. And one step at a time, 0.8 to the 0 is 1, so that became 2. 1 plus 2 is 3. 12 over 3 is 4. Okay? Now, horizontal asymptotes, where are they? Well, I want you to think about something for a second. Aren't the horizontal asymptotes the end behaviors?
Oh, wait, no.
So, like, the further I go this way, the closer I get. The further I go this way, the closer I get. So what I want you to think about is this. What happens if I let x get really, really big? So infinity, going to infinity. What happens when I let x get really, really big? Well, think about it. 0.8 is like 4/5, 80%. What happens when you take 4/5 and raise it to really big powers? Try it on your calculator. Take 0.8 and raise it to the 100th power.
Oh, I know. It's really small.
It's going to get really small.
Like 1.
Really small. So this right here is going to get really, really small. Which is like 0. So this is gone. It becomes so small. So where's that asymptote? Y equals 12 over 1?
12.
This is going to 0. But I have 1 plus 0 down here. So my top asymptote is going to be at y equals 12.
So what if the 8 was like a 3? It would get bigger.
Okay, so that's the next thing we're going to talk about is what happens is as this gets big negative.
Oh,
Well, then it becomes, instead of 8 over 10, it becomes 10 over 8. And what happens when you raise 10 over 8 to big powers? Huge. So now, this is huge. So I have 12 over huge. What kind of a number is 12 over huge?
Small.
Very small. So my top asymptote is at 12 over 1, and my bottom asymptote is at 0. My bottom asymptote's at 0, and my top asymptote is at 12. So what do you think about B? Where do you think you're going to have one of your asymptotes in B? One's at 0,
18.
and one's at 18. Where do you think you're gonna have them in C?
0,
0 and 9. Yep, 0 and 9. They're gonna be at 0 and 9. Those are gonna be your asymptotes. Okay, so tomorrow we will continue on with this discussion. We're going to finish this tomorrow, so if you want to start working on your homework now, you can, but I'm going to sign it tomorrow, which means it'll be due on Tuesday. Everybody got all 3 papers?
What?